Welcome to Robominions.in AI interview preparation app. The topic of this video is creating binary tree. So creating binary tree, we before moving forward with the tracing of the code, I'd request you to watch this video on your laptop or a bigger screen so that you can clearly visualize the code. Okay, and also please download the Robominions.in AI interview prep app so that you can, after watching the video, you can trace your code yourself as much as time as possible and revise the concepts. Okay, so the app is available in the website robominions.in, and click on download latest version here. Let's get back to the tracing of the creating a binary tree. So I click next. So use next and back button for code control. So you control the code using next and back button, and use menu button to return to menu. So here you can see there is an arrow, right? So arrow will go to the execution line, like whichever code line is getting executed, it goes to that line. Okay. So now hash include stdi.h, then hash include stdlib.h, then it goes to int main. So in the int main we have a node pointer, type def struct node. So we have renamed the struct node with node. So this structure has member variable int data. We have struct node pointer left and struct node pointer right. So these are the member variables, so left and right. Okay, so this you have to follow this convention while like tracing the code. So a node in the binary tree has a left child, there is a data value in between, and a right child, and there is a node address of that node. Okay, so let's begin. So we call the function create binary tree. So goes to create binary tree, and it returns a node pointer. The root is of type node pointer, so it returns node pointer. Now first again we create a node pointer root equal to the scope of this root is within this function only. Okay, so we call create underscore node. We send data 10, so it goes to create underscore node, data is 10. So we create a new node pointer pointing to the memory location. So the size of that memory is size of the node, and it is typecasted to node pointer. So we see it goes to node. Here we have a so we have allocated the memory. Right now it has a garbage value. The address is hash 100. So G stands for garbage value, just a naming convention. Then we have new node data equal to data value. So the data value which was passed was 10. So 10 has been added to the node. Then new node left equal to null. So null, left is null. New node right equal to null. So right is null. Then return new node. So it returns the new node to the root. So now root is pointing to this node. Now we have function insert to left. So it goes to insert to left. So we send root, this root pointer, comma, the data value. So it receives the insert to left. So we have a root pointer here receiving. So it receives the address to, that is, it receives, this pointer receives hash 100, the address of the node. Now this root pointer will be pointing to this node. Okay, then we have int data 11, right? So now root left is this, again calls create node. So it goes to create node, new node. Now again new node is done, another memory is allocated. So this time it is hash 200 memory location with the garbage value G. So now data is inserted. Now data value is, we received the data, right, 11. This was passed, so data value is 11. New node left is null, new node right is null. Return new node, so it returns the new node. So you can see root of left. So the root was pointing to this node, right? So the root of left is now pointing to the new node which was returned by the create node. So now hash 200 address is added. This hash 200 address is added here. So that is the reason it is pointing here. So we have successfully inserted a left node to the binary tree. Okay, now returns root left. So the root left will be returned. So we are not receiving any return. If we needed it, we can use it. Right now we are not using it. It returns. Then we have insert to right. So now we call the, so we have inserted to left. Now we call the insert to right function. So goes to insert to right. We have sent the root pointer. So you have sent root. So root is still pointing to this node. Hash 100 has been sent to this pointer. The data is 12. Okay. Root right equal to create node. So now root right will, this is root right. So right side will get the address of this new node which will be created. So we'll be going to function create node. So goes to create node. Again new node is created. So you can see new node is created. This is pointing to hash 300 address, and right now garbage value. Okay, now new node data is added. The data is 12, right? We sent this data, so that is added here. Data value 12. Then we have new node left equal to null, new node right equal to null. Okay, then return the new node here. Return the new node address. So that will be going to root right. So root right has received the hash 300. It has been updated. So I hope you have clear visualization of how a binary tree is created. Now this returns the root right. Root right has been returned. Okay, it's not received on the other side, but that's fine. But we have returned. Okay, if in case you want to modify the function, then you can modify the way you want. Okay. Now again we call insert to left. So insert to left, and we are sending the root left as a root. So root left is this. Now this time the root will be this one. Okay. So it goes again insert to left. So now we are going to insert data value 13 to the left of this node. So let's see. Goes to insert to left. Root left equal to, so root left of this node goes to create node. So creates a new node. So a new node is created at location hash 400. Comes back. New node data is now 13. 13 is added, hash 400. Okay. New node left is null. New node right is null. Returns new node to the root left. So now root left is this one. Okay. Don't, this is the main root, leave that. But we have sent root left. So root left of left. So that is what is happening. So you got, so you sent root left to this. So address of this. So this root has received hash 200. So then after, so this root is pointing here. That root's left is this one. So that is why root left has received. So root left has received hash 400, the address of this node. Okay. I hope it's clear now. Now it returns the root left. Okay. Then we go to insert to right, root left. We are sending the root left. So again root left is this node. So we are inserting right of this node. Okay. The data value 14 goes to the insert to right, root right. So root left was sent here. So this will be root left right actually. So because we already have hash 200 in the address, that is the reason we are directly doing root right. Okay. So now root right we'll call create node. So new node is allocated with a memory. So we got a new node with a memory hash 500 and has a data garbage value. New node data equal to data value. So data value is 14. Left is new node left equal to null. New node right equal to null. Then return the new node. Okay. To the root right. So root right is now, so you can see the root right has been updated with address value hash 500. It is pointing this way. Okay. So return root right. Okay. So one side is successfully done. Now let's insert to left. So we call insert to left and send root right. So root here is this root. So root right is hash 300, that is this address. So this node. So root right address of this node is sent to the insert to left function. So hash 300 is sent here with the data value 15. So insert to left received hash 300. Now hash 300's left. that is this node's left is null, so we call the create node on for this node. Okay, goes to create node, new node. Now memory is allocated with hash 600. New node data equal to data value is 15, so 15 has been added. New node left equal to null, so new node left is null, updated. New node right null is updated. Then return new node. So once it returns, root left has been updated. You can see hash 600 is added. Now returns root left to the main function. Then we have insert to right, root right. So root right is sent again, hash 300 is sent here. We are going to add 16, so a new node will be created here. Let's go to insert to right, root right is this side. Root right now is null. We call create node on that, so goes to create node, new node is created, memory is allocated for the new node. So we have a garbage value data, and hash 700 is the memory location, so new node is pointing to that. New node data is 16 is sent, right? So 16 is added here. New node left is null, new node right is null, null is updated. Return new node to root right. So root right hash 700 has been successfully added to the root right. Then return root right to the main function, and then return root. So this root is returned, create binary returns the root to the main root. So now main root is pointing to this main root. Okay. Then return from the main function. So the time complexity of this algorithm is order of 1, because we don't have any loops, we are inserting one by one. So it's a order of 1 time complexity for inserting. If you are iterating, then it would have been order of n. Okay, for traversal. Order depends on the height, and it would have been log n. Okay, depends on the traversal. If you want to access the code and want to check yourself the address and put logs, click on the code button in the Robominions.in AI interview prep app. To download this app, go to the website Robominions.in and click on the download latest version here. If you have if your laptop is a Windows OS, then download for Windows OS and click on download anyway. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.